Control of multi-link manipulator, linearizing and decoupling of terms from the nonlinear as a significant advantage. Why is this nonlinearity mentioned relative to error equation alone? Is it about nonlinearity arising due to dynamic effects? Or is this something else altogether? Also, are the advantages of linearizing and decoupling related to computational ease or they related to performance of the system? Okay, I'll just open the slide and keep it ready. So when this person joins, I can explain. So where are you right now, Shamo?
Home, sir. Uh, so I'm planning to maybe come next week.
Next week. Okay. We need to do something else because nobody is there. So
Okay, yeah, I think that Yogesh from others, the CAD lab he was mentioning,
that
then the chairman.
yeah,
Yeah,
that is one thing. And the second thing is the CK, computational kinematics. They have sent me one email.
okay, okay. So in YouTube, someone has asked, so he's Michael. He
Ah,
says, what are the starter protocols we need to know to start the journey with robotics?
Arthur protocols. Okay. So, Michael, welcome to this. Uh, Michael, right? His name,
Oh, he's in YouTube. You can't, means he can't read your chats.
oh,
So you can
oh,
just speak, he can listen
okay,
there.
okay, fine. So, Michael, this is Professor Ghoshal. Welcome to this live stream of robotics basics and selected advanced concepts. So, if I understand your question correctly, starter is basically what sort of prerequisites do you need to, you know, do robotics? So, as you know, robotics is very interdisciplinary. So, some of the basic things that you need to learn if you want to do this mechanical part of robotics, which is what primarily this course is about, is linear algebra, mechanics, and some basic mechanical engineering and maybe controls. So if you look at some basic courses in linear algebra and then mechanics means things like Newton's law and Euler's equation and so on. And then control, then you should be set to take up this course. These are the main prerequisites for the robotics, this course. If you want to study robotics as it is understood elsewhere, like if you want to go to AI, ML, and all these other newer things, then you need to do several computer science courses. You may also need to do some statistics and various other courses. I hope that is clear to you, whatever I have said.
So he says, I have a bachelor's in computer science and a master's in data science. I
Hmm.
am well uh, with computation. I am looking for actual implementation.
Okay. Yeah. If you want to do real implementation, the simplest thing is would be to go get yourself and depending on what level you want to do implementation, the simplest thing is to go get yourself a robotics kit. Okay, so earlier there used to be someone Lego kit, Lego Mindstorm. I think that is no longer there, but there must be something equivalent. Uh, a robot kit. There are also lots of various simple robots, both wheeled mobile robots and stationary robots, which are available off the shelf. So you need to maybe buy some of them. So please just take care that you buy something where you can do some programming. It is not just a toy. So you have some access to the uh, you know actual controller or actual kinematics or dynamics and so on. And of course, the other way of to do it would be to go, you know, go join a company which is doing robotics work.
He says, thank you, sir. I want to know if there are any ways to talk with SOC and get a response. I might have to look into embedded programming to do this. Thanks for sharing this.
What is SOC?
So system on chip.
Oh, okay. I don't know. I don't know that. I'm sorry, I'm not very familiar with the system on chip and VLSI and various other, reasonably advanced electronics. So yes, you have to, I guess you have to search. So I think he's also using the chat window.
No. So
So,
that is actually just from NPTEL side, they are posting the same texts
okay,
directly.
okay. So this Ninad Mehta, uh, he uh, he was in this chat window. So is he in YouTube or I can't see him?
No.
Like,
Actually, he's not. Yeah, he's not. So this question was posted in the discussion forum a few
uh,
days back. So
so
maybe you can just discuss, and I'll tell him to just watch this recording. Okay.
okay, so that's what I will do then. So if you can see, Ninad, I'm going to share my screen and I will show you the part which I think you are uh, talking about. Okay, so this is the part. Shomo, can you see my screen?
Yes.
Okay, so what I'm showing you here is this something called model-based control. Okay, so in this model-based control, so this is my robot. Okay, wait, I need to do it slightly better way. So let's just do it properly. Not this one, the next one. Um, I think somewhat this is week 10, right? Yes.
Yes.
Okay. So uh, I think, Ninad, we are discussing about this control law partitioning or model-based control. So for any robot, the input is this torque at the motors, and the outputs are rotations at the joint and the angular rates. So this is the normal robot, start from the very basic. So instead of doing this, so normal PID control is something like Kp into some theta d minus theta plus Kb into theta d dot minus theta dot plus maybe an integral term. Okay. So this is a normal PID controller which is used. Instead of a PID controller, in a model-based controller, what we will do is we will do the following. We use this part. If you can see my block which I'm doing. So in a model-based controller, so this tau prime is the same as the PD controller, or actually not PID, but PD controller. So it is Kp into theta d minus theta plus Kb into theta d dot minus theta dot plus some theta d double dot. Okay, so this is the tau prime. But what we are going to do is we are going to scale tau prime with something called alpha. So alpha into tau prime, plus we will put a bias term which is beta. And nicely, we will choose alpha as this mass matrix and beta as this nonlinear terms, which is the Coriolis term. This is the gravity term, and this is the friction term. Okay, and where do I get these terms from? This is from the equations of motion. So if you look at my slides, previous slides, so these are called you derive the equations of motion. This is called the mass matrix. Okay, and this is the Coriolis term, this is the gravity term and friction term. So this is known if you derive the equations of motion. So we are going to choose the torque which is going into this joints or into this robot as alpha, which is mass matrix times tau prime, plus beta, which is this bias term, and tau prime, which is the PID part. So now if you were to do this, okay, so what you can see here is this is one part of beta, and this is the other part which is mass matrix. Okay, so this is the part which is tau prime. At here I have tau prime. So tau is equal to m tau prime. So you can see m, and then tau prime is coming in here. So tau prime into m plus beta. Okay. So this is what is called as a model-based controller. Basically, why model-based? Because we are using the model. We are using the mass matrix. We are using the Coriolis term, which we are using the gravity term, and some effect of friction. So now, if we were to do this, what you can see here is that you will get, if you were to go back and see, this is the PD controller, because I is also there, but PD is enough, that you will get something which is called as a linear error equation. Okay. So the error equation now is linear, decoupled, and very, very easy to figure out. And this works out. So you can just substitute what is tau prime and alpha and beta in that equation. And this is what is shown here also. If you put this and then you go back and substitute here, you will get tau prime is equal to q double dot, which in turn will give you this linear error equation. So as far as your question is concerned, in the question, so I think you are asking whether what exactly is meant by this. Okay, this is what we mean, that all the nonlinearities and coupling are cancelled, and the original nonlinear equation, which is modeling the robot which we are trying to control, is reduced to a set of decoupled linearized equation. Okay, so that is what is shown in this block diagram. So at this place you have Kp into, at this place you have Kp into theta d minus theta, and this is Kv into this, and then you add to this and you get tau prime, and then you do this. Okay, so I don't know whether this is clear. This is what we mean by model-based control, and this is what we mean by linearizing and decoupling. So it is linearized in the sense that the effective system is now a set of non-linear decoupled error equation. Okay. So the main advantage of linearizing and decoupling is you are getting, in some sense, quote unquote, getting rid of the nonlinearities, which is there in a robot. And as you can see in that slide, as you can see later, if you do this model-based control, and if you get rid of this nonlinearities in the way I showed you, then you will get much better improved performance. And those are shown in the slides for simulated robots as well as some actual experimental data for a robot which we did long time back. So I think from that should be enough. You can request Nirav to
Yeah,
see.
I'll ask him to check this
Yeah.
video.
Yeah. So are there anybody else? I can't see. Okay, yeah, there is nobody else. Any other message either on YouTube or on the live or in the forum?
Yeah, no, he's just means like asking the other means like the organizer some question. That's it.
Okay.
So he just said I'm working on project Amazon Kuiper, but I am utilizing what was fed to me by other team as SDE. I am looking into how I can leverage my knowledge in CS and DS to get ahead. Mm. I somehow ended up in this discussion. Have a good one, you all.
Okay, what is DS?
I think data science probably,
Okay,
or data
data.
structure. I'm
Okay.
not sure.
Okay, fine. The Amazon Kuiper is like, I think, that system of satellites which Amazon is trying to build to compete with Starlink, Musk's Starlink. So yeah, I'm not very sure how you can use uh, model-based control unless some of these satellites can be controlled using model-based control ideas. So nobody, Shomo, nobody has asked about the uh, assignments or the final
No,
exam. Okay.
no. Just yeah, no. All the um, weeks are now uploaded.
Hmm.
Uh,
Hmm.
yeah, that's it.
When is the final exam?
So I think on 24th or 25th,
Oh,
probably.
okay. Okay.
So maybe you can just tell a few lines what they can expect in the final exam. So like MCQ and all. Yeah.
Okay, I'll repeat it once more. So, all
No, you can just speak because no one is here. They can't read your chat. So the
okay.
recording will still be there.
Okay, so I just the TA is, suggested that I speak a little bit about the final exam. Uh, the all the questions will be MCQ type. Okay, and there'll be 50 approximately, I think 50 questions. So you need to prepare uh, the material which has been taught in all these modules. So most of the questions will be based on the assignments. If I remember correctly, close to 50% of the questions are based on assignments, and only some 15 to only about 20% questions are open-ended, and the rest of so another 20-30% will also be from the material in the lectures, but maybe with some little bit of twisting. Okay, so please prepare all the various modules, and also please take a look at all the assignments that you have done. The final exam will be based majorly from the assignments and the slides. Do you want to add anything, Somo?
Yeah, just the questions will be means like all tests like MCQ, MSQ, and numerical. So not only MCQ. That's it. Yeah.
Ah, yeah. No, there is no MSQ. There is only one answer for each question, as far as I
No,
remember.
no. Uh, there could
There,
be. Yeah, there could be. I think, and I think numerical is also there.
yeah, numerical is
Yeah.
also there. That is correct.
Yeah.
So please, yeah, as a correction, uh, there will be some questions where you have to do some very simple computations and then type in the answer. Okay, or you have to do some computation and select from a set of numerical answers. And again, as I mentioned, and I'm repeating, most of it, most of the final exam will be based on the assignments and also on the material which are there in the slides. Yeah, close to 80% of them. And some only 20% will be sort of open questions, quote unquote open questions, where you have to think a little bit. So good luck with the final exam. This will be the last meeting in this course on robotics. We still have a few more, another maybe 20 minutes. So if somebody wants to join, this is the last time you can either catch hold of me or the TA, Of course, you can always post questions in the forum or send email to the TA. But if you want to do it one-on-one like this, then this is the last time. We will not have any more meetings like this. So Bharat, we'll wait for a few more minutes. So it is yeah, it's in 3:17 now. So maybe 3:20 or something like that. We'll wait then and then we can close this. Is that
Yes, sir.
okay?
Sure, sir. Okay.
Hmm. Did you have, Shoma, did you have any meeting with the PMRFTA?
No, just I think one student of the same Ninad, he was having some issue with joining the live sessions. So I intimated, I think his name was Amritanshu. So he told that he'll look into it. But yeah, I mean, he means like he didn't come back with any queries or any doubts or something like that.
No, there was a TA who was a PMRS student, no?
Yeah, same.
Same,
Yeah,
same person.
yeah.
Okay, fine.
So actually, not Professor Koshal, but from NPTEL side, maybe you can look into the comments Michael has been making. So I think they can probably sponsor some kits from Amazon's side. So maybe you can take a look and uh, yeah.
What? Repeat, Shoma. What has Michael
So
has been saying?
I think
Yeah.
he was saying that um, just to go through it. So he just said that please let us know if we can sponsor kits from Amazon side. So this is to the actual the coordinators of NPTEL.
Okay.
Yeah.
Okay, Bharat, are you
Yes,
there?
sir. Yes, sir. Yes, sir.
So you can see, what Michael, he works in Amazon, I think. So they are willing to be associated with some way with NPTEL.
Okay.
So maybe you can pass on this message to the NPTEL coordinator in IIT Madras.
Okay.
That this is what one person from Amazon had mentioned. So they can take it forward if they want to.
Okay, sir. Can we wrap up this session, sir?
Yes, I think so. So just let me just thank everybody. Anything. So this is Prasad Ghoshal and Somakanti Mahapatra. This was our last meeting. So unless you have some questions, good luck with your final exam. Thank you. Thank you very much for joining this NPTEL course on robotics.